This is section 3 of chapter 3, and we're talking about zeros of a polynomial functions. And first thing is we're going to talk about the factor theorem. The factor theorem says that for any polynomial f of x, where x minus k is a factor, right? 12 divided by 4 is 3, right? So that means 4 and 3 are factors of 12. So that means x minus k would multiply by something to get to the polynomial. That polynomial f of x. And so x minus k is called a factor if and only if f of k equals 0. So I have a couple examples in here that kind of shows it. So basically what it means is if I add a point, say 2 comma 0, that means here's my x equals 2. That means x minus 2 would be a factor of some polynomial. Right, so that means x minus 2 times some other polynomial, times some other binomial, or some other factor would equal the polynomial. So here are a couple examples. Is x minus 2 a factor of this polynomial x squared minus x minus 2? So basically what that's asking is there something that I can multiply by this binomial to get me this one? Right, I have no remainder. Right, 4 and 3 are factors of 12 because 4 times 3 equals 12. There is no remainder. Like 5 and 2 would not be factors of 12 because 5 times 2 is 10, and I would have a remainder of 2. Okay, anyways, so you got to set this equal to, you got to find out what x is by setting this equal to 0. So x is equal to 2, and then we're going to run through synthetic division. So we list our factors in order. We start at a squared, so that means we need to go squared, our linear term, and then our constant. So nothing is missing here, so we don't need to put a 0 anywhere. Put a 0 on the second line, and we're going to add the first line and the second line. So we get 1, and then whatever lands on the third line below the third line down there, we're going to times by what x equals, 2. So 2 times 1 is 2, and then minus 1 plus 2 is 1, and 1 times 2 is 2, and does equal 0. Our remainder is 0. So we learned from last section that means that 2 would be a 0 of our, or would be a solution or x-intercept or anything like that. So that means since I got a 0 as remainder, that means that x minus 2 is a factor of f of x, of that polynomial. And and we can see that because we could actually multiply this out, x minus 2 times this polynomial right here, which would be x plus 1. And if I FOILed that out, you can see that I get x squared minus x minus 2. So x minus 2 is a factor. Okay, so you could try this one on your own if you wanted to. Okay, so I'll also do this one. Again, you set what you're asking to see if it's a factor or not. So we're trying to see if x equals 2 when we put through synthetic division gives us 0. So we start at 4 as our exponent, and we're missing a 3 exponent, so that means I need to put a 0 in for my coefficient. I have 2 exponent, I have 1 exponent, and I have 0 exponent. So those are all good. 0 on the second line there. Add those two rows together, we get 2. What multiplies on the third row is what our x is 2. Or sorry, what did I write 2? Is positive 1, so we get 1 times 2 is 2. We get 2 plus 0 is 2. 1 times 2 is 2. We get 5. 5 times 1 is 5. And then 1 time, add those, we get 0. And 1 times 0 is 0. We get 7. So no, x minus 1 is not a factor because we didn't get a remainder of 0 at the end. Right, so what that means is x minus 1 times this polynomial right here, 2x cubed plus 2x squared plus 5x plus 0 with the remainder of 7, right? So that means this one, 2x cubed plus 2x squared plus 5x times x minus 1, and then I would have to add this 7 over x minus 1. to this in order to get that original polynomial there. Okay, so now the next is going to be finding other factors. So if negative 3 is a 0, that means that x plus 3 is a factor. So we're already giving a factor. We're already given one because negative 3 is a 0. That means x plus 3 is a factor. We want to find the other ones, right? So we're going to use synthetic division again. Make sure all these terms are accounted for, which they are, right? My degree is 3, so I should have 4 terms, which I do. 0 in the second row there. Add those together. What we're going to multiply here by is by our 0, which is negative 3. Right, so we're going to run this through, and we know we're going to get 0 at the end. Right, so if you don't get 0, then check your math in here. Right, so we got 0, so that's good. Now I'm going to list this polynomial. Right, this is drops down in 1 degree. Right, it was a cube, now it's a squared, so 6x squared plus x minus 1. So that's our new polynomial that we're going to work with. And now what I'm going to do is I'm going to factor this polynomial. Because it's a squared, I'm going to factor it. So we can factor this polynomial. We can do cab, c times a, which is negative 6. We can find our b, which is 1. What times what is 6, but adds up to 1. That's a 2 and a 3. And I'm going to take 3 minus 2. So it's x plus 3. X minus 2, and then I'm going to divide by my a, which is 6. Reduce these fractions. So I get this is reduced down to 1/2. This is reduced down to 1/3. Now I can bring those denominators out front. So 2x plus 1 and 3x minus 1. So we can see if we FOIL that out, we get back to this polynomial. So that means x plus 3 was a factor. They gave us that one. So these are the other 2 factors. And I believe that's what it asked for. Or does it ask for find the other zeros? Just find the other factors. So those are the 3 factors. Okay, so homework for those type of problems is page 315, 5, 7, and 17. So I'm going to start those now on this video, so I will do those at any time. You can look at the examples, then try them, and then if you get stuck, come back to the video and watch it. Okay, so here's number 5. We're given a polynomial, and we're asked if x minus 1 is a factor of it. Right, so we set that equal to 0, so that means x equals 1. So we're going to plug 1 into synthetic division. We're going to list our coefficients, make sure we're not missing anything, which we're not on this one. Put 0 in for the second row. 1 plus 0 is 1. 1 times 1 is 1. We get minus 4. We get negative 4. We get negative 1. We get a negative 1. And we get 0. So yes, it is a factor. Yes, x minus 1 is a factor. Okay, here's number 7. 4, 3, 2, 1, 0, so all our exponents are in order, so we're not going to miss anything here, and we're asked if x plus 1 is a factor of this polynomial here. So we can go ahead and list our coefficients. We have 2, 5, negative 8, 3, and 13. 0 goes in the second row, we add those, then we multiply what's on the third row, lands on the third row by setting this equal to 0. So this factor equals 0, so that means x is negative 1, so what's going to go in the box is negative 1. So 2 times negative 1 is negative 2. Add those up, that's 3. 3 times negative 1 is negative 3. Negative 3 minus 8 is negative 11. We get positive 11. We get 14. We get negative 14. And we get negative 1 at the end. So this is not 0. So that means it's not a factor. X plus 1 is not a factor. Okay, so here, number 17, they give us our polynomial, but this time they actually give us a 0. So k equals 2 is a 0, and we want to find the other factors. So if k equals 2 is a 0, that means that x minus 2 would be a factor. So that's one of the factors. And now we're going to run through synthetic division. Make sure all your coefficients are taken care of. There's nothing missing. It is a degree 3, so that means there should be 4 terms, which we have. 0 in the second row. Add those together. What goes on the box in the third is our k, which is 2, or x, which is 2. Then 2 times 2 is 4, so we get 1, which is 2, is negative 15, is a negative 30. Add those, we do get a 0, which we knew that was going to happen, right? Because they said that k is a 0. So now we drop down a degree because we had a cube, so now this is a 2x squared plus x minus 15. And now, since it's a quadratic, now we can factor it with cab. C times a is negative 30, and b is 1. So what times what is 30, but subtracts to 1? So that would be a 5 and a 6, right? And then 6 minus 5 would get you 1. Okay, so that means that x plus 6 and x minus 5. Now we gotta, don't forget to divide by your a, which is 2. So x plus 3. That doesn't divide, I can't reduce it, so put the 2 out in front. And then you could actually multiply this together and make sure, right, that it comes back to that polynomial, and in which it does. So we're good there. Also, excuse me, if you multiply those together and then you multiply by what the other factor is, right, which they gave us was x minus 2. If we multiply all 3 of those terms together, right, we'd multiply these 2 first, we'd get this. Then we would take this trinomial, multiply it by this binomial, and we'd get back to that original polynomial. So those are all your 3 factors.